So, welcome to the third and final installment of your algebra techniques to find limits when direct substitution doesn't work. So if you remember in the previous videos, the first way to do that is to factor if you have a quadratic or something like that. So I showed you how to use the difference of perfect squares and just how to factor by guessing and checking. The second method was rationalization. So that's when you have like square root in either the numerator or the denominator. You need to rationalize either one of them by multiplying by a big old factor of 1. Now, our last and final installment is what do you do if you have fractions in your numerators and denominators? What do you do with those? And what we call that is simplification. So I'm going to show you my window, and we are going to work through a couple problems that show how to do simplification. So right now you should be able to see this is our last set of notes. It was on rationalizing. So let's go to our next page. And the next page is our third and final technique. It will be, I think, somewhere near September 14th, 2020. So put whatever date it is. But this last and final technique is called simplification. You oftentimes call this finding common denominators. Okay, so we are going to very often, have to find common denominators in fractions. So let's kind of get started, okay? I'm going to write down our first problem, and it's going to look very similar to the ones we've seen before. So let's say I gave you j of x equals this function, 4 over x minus 1 in the numerator, okay, all over x over 4 minus 4 over x in the denominator. So notice, you have groups of fractions in the numerator, you have groups of fractions in the denominator, and we want to find the limit as x approaches, I'm just double checking where it is, x approaches 4 of j of x. Okay, so we are looking for that value. So the first thing, remember, I always tell you to do, always check direct substitution. Again, if you can do it quickly, great. I will show you all of it in these problems, but you don't have to always show it unless they ask for it on the test. So if we do direct substitution, you get 4 over 4 minus 1 in the numerator, and you get 4 over 4 minus 4 over 4 in the denominator. So 4 over 4 is 1, minus 1 is 0, 4 over 4 is 1, minus 4 over 4 is also 1, so that is 0. This, again, is the indeterminate form. And you'll notice that I've written it several times, indeterminate form. You need to remember that phrase. When you have 0 over 0, it's the indeterminate form. So now let's start the process of simplifying this problem. So we need to start from the beginning. And we have 4 over x minus 1. And then we also have x over 4 minus 4 over x. So you need to get a common denominator for everything in the numerator, and you need to get a common denominator for everything in the denominator. So let's talk about some quick ways to figure that out. So if I have 4 over x, okay, minus 1, if I'm going to get a common denominator, I have to multiply the 1 by whatever the denominator is here. So, but remember, like in the previous problem, you can only multiply by a factor of 1, so I have to multiply by x over x. So what you get is you get 4 over x minus x over x. Okay? Now, remember when you combine like terms, you now have 4 minus x over x. So what I did is I just went through and we're just working the numerator first. So this is now my new fraction. I have 4 minus x over x in the numerator. So what do I do with the denominator? Well, with the denominator, I have a couple of things that I have to do. I need to multiply by 1 for both of those things to get them so they have a common denominator. So the first one, the denominator here, and this is just kind of my shortcut, the denominator for this fraction is x. So I'm going to multiply this as x over x. Okay? And you'll notice that right here, the denominator is 4. So I'm going to multiply the other fraction by 4 over 4. So when I go through and do all of that multiplication, I get x squared for the first fraction over 4x minus 16, because 4 times 4 is 16, over 4x. Okay? So when we combine and put these all together, we get x squared minus 16 over 4x. So here is the fraction that we are now working with. Notice it seems almost even a little more complicated at this point, but it's not that bad. We're going to just keep simplifying this down. So what we're going to do is I'm going to slide right over here to continue the simplification process. So if you remember, when you divide by a fraction, you have to flip and multiply. So that's what I'm going to do first. So you need to remember a lot of algebra when we do this. So you need to flip and multiply the bottom of that fraction. So it's going to be 4x over x squared minus 16. Now, what should start to happen as you keep simplifying this is things should start canceling out, okay? So if we go like that, the two x's cancel out, okay? So we now have 4 times 4 minus x over x squared minus 16. Okay? Now, we could keep simplifying this, but what I'm going to do is I would like to, at this juncture, do a direct substitution to see if I get a value. Okay? If I get a value, then I'm done. If it still turns out to be 0 over 0, then I need to keep simplifying it more. So I'm going to try now at this juncture to find the limit. So I'm going to say the limit as x approaches 4 of this function. So I'm going to plug that stuff in. I'm going to do 4 and then 4 minus 4 over 4 squared minus 16. So I have 4 minus 4 is 0 times 4. It's 0 over. Oh, still have a problem. So I need to simplify this more. So here's what we're going to do. So let's take a look at this part right here, and let's try to simplify it some more. I can see that down here in the bottom, it's x squared minus 16. I know in my head that that's factorable because that's the difference of perfect squares. So I have 4 times 4 minus x. Notice I'm not multiplying anything together just yet. Because I'm thinking something's going to kind of factor out. So this is going to be x, and then we have plus 4 and minus 4. Remember, we have the difference of perfect squares. So take a look at this now. When you look at this, we are, ooh, do you see that it's kind of close? We have 4 minus x up here, but we have x plus 4 here, not exactly. Then we have 4 minus x here, but this is x minus 4 here. So these two are just slightly different. There is a little trick that we can do when we have the x being negative, okay? And that little trick is we can take out -1 from everything in this one. So if I take -1 out of 4 minus x, that changes the sign on everything. So I'm going to bring the -1 out, and then I'm going to change the sign on everything in the top part of this fraction. So it's going to become -4 plus x, and then I still have in the numerator x plus 4 and x minus 4. Okay? So you need to recognize that there are some things in here that can be canceled out, even though they don't look exactly the same. This one is -4 plus x. If you flip the order, it's x minus 4. And this one also is x minus 4. So those two can be canceled out. So now that we've simplified it even more, let's find the limit of what is left over. I still have -1 and 4, so it's going to be -4 on the numerator. And then in the denominator, I have x plus 4. So do direct substitution. So now we have -4 over 4 plus 4. So it's -4 over 8, which equals -1/2. So our final answer after all of that is -1/2. One thing you're going to have to start realizing is AP Calc problems are oftentimes going to take a lot of work. So you need to really be thinking it through and trying to figure that out. So notice in the beginning, though, I did back here go through and I did test it once just to make sure, but it still was 0 over 0, so I had to simplify more. Okay?